Alright guys, hi. Okay, so this is now a problem of waves. Okay, it says calculate the wavelength of a sound that travels at 330 meters per second and has a frequency of 440 hertz. So the first thing we have to know is that we have a formula in which we already have the wavelength, that is the lambda, the lambda Greek letter, the speed, and the frequency. And we already have data, and the problem is 330 meters per second is the velocity and the frequency of 440 hertz. So to calculate the wavelength, we only have to divide that. That's 330 meters per second divided by the 440 hertz. There it is, hertz. So as a result for this, you'll have 0.75 meters because it's wavelength. Okay, so that is for this first problem. Okay, now we have another problem right here. Okay, so this is the other problem. Now we have to calculate the frequency of a sound wave that has a speed of 330 meters per second and a wavelength of 0.5 meters. Okay, so we already have the same formula, but now we want to have the frequency. So we have to isolate the frequency. So to isolate the frequency, we only have to divide the speed by the wavelength, and that's the formula we will use. So the frequency will be equal to the speed, that is 330 meters per second, divided by the wavelength, that is 0.5 meters. Okay, and once you do it, you obtain that is 660 hertz because it's frequency. Remember that hertz is like saying seconds to the -1 power. Okay, alright guys, so also remember that frequency is the number of waves per second. So this means that you have 660 waves each second in this sound. Alright, so that's everything for this video. These are just two wave problems, and that's it. Goodbye.